In this video, we're going to talk about linear functions and the different forms, so slope-intercept, standard, and point slope form that the linear equation can be written in. And so the most important part about a linear function is that there is a constant slope. So in order to have a straight line on a graph, your rate of change, so the steepness of that slope, is going to remain constant. That's what creates the straight line. So before we look at those different forms, let's just ensure that we understand slope first. So if I'm given 2 points, I can find the slope between these lines of the line that connects them by a couple of different methods. So first, I'm just going to put them on the graph so we can just look at the vertical change in comparison to the horizontal change. So if I'm looking for the slope of a line that contains the points -4 and -4, I know I'm going to go over -4 and down -4, and 2, 5. So what I'm going to do is I'm going to connect these points, and then we are going to find the slope that this line creates. So what I need to do when I'm trying to find the slope of a line is I need to find 2 points on this line, which I can choose the 2 coordinates they gave me, or I just need to find 2 coordinates that fall exactly at the intersection of the grid line so that I know exactly where that coordinate is. So I could choose this point, the 2 that they gave me, or this. So notice that these points that I picked fall exactly at the intersection of the grid line, so I can see exactly where they are located for when I try and calculate my slope. The next thing I'm going to do in order to calculate slope using a graph is I'm going to connect my dots with a right triangle. So I'm going to follow the grid line and connect the dots to make a right triangle. It doesn't matter if you go that way or this way, you will get the same right triangle, just a different orientation. Then I'm going to count my vertical change, which is 3, and my horizontal change, which is 2. And I'm going to put this as my rise over run, or my vertical change over my horizontal change. So our rise, our vertical change is 3, and our run, or our horizontal change, is 2. So my slope is 3 over 2. And that's positive because my line is going upward. So I just want to always make sure that I take note if my line is creating a positive slope or a negative slope and give the slope that sign. Another way to find slope, if you can't create a graph for it or you just don't want to create a graph, is you can actually use this slope formula. So our slope formula is y2 minus y1 over x2 minus x1. This can seem a lot more intimidating than it actually is. My direction is to always label your coordinates. So this first coordinate is our x and y, and then we've got this second coordinate, which is an x and a y. And I'm just going to use this little tiny 1 so that I remember that this is one of our coordinates, and then our little tiny 2 so that we know that that's our second coordinate. And then I just plug in those numbers into my equation. So I've got y2, which we said is 5, minus y1, which is -4, so we're subtracting a negative, over x2, which is 2, minus x1, which is -4. Remember that when you are subtracting a negative number, you're going to connect your dots and connect your negative signs and make it into a positive. So this is going to end up as 9 over 6. And if we simplify 9 over 6, we get 3 over 2. So those are just two ways that we can find this slope, this constant rate of change. So that's kind of our introduction to linear functions. Now we're going to look at the three forms that a linear function can be represented by. So we've got slope-intercept form, where we have it in a format where I can easily see the slope and I can easily see the y-intercept. We have standard form where x and y are on the same side, and we have point slope form, which is important because it gives me one coordinate and the slope. So if you're ever given one coordinate and the slope, it's easy to use this form in order to bring it back to a easier form to use. So like something like slope-intercept form. So if I am looking at this slope-intercept form, the way I'm going to graph it is I'm going to see my y-intercept and I'm going to see my slope. And this is going to allow me to easily put this onto a graph. So my y-intercept is the point where it crosses the y-axis. So I'm going to find -2 on my y-axis and I'm going to plot a point. And then my slope, remember, is my vertical change over my horizontal change. So if we want to just look at our slope a little bit bigger, we see that it's a 3/2 and it's positive. The top number tells me how much I'm going to go up or down. And because it's positive, we're going up. And the bottom number is going to tell me how much I'm going to the right. So we're going 3 up, 2 right. And then I can repeat this a couple of times so that I have a couple of points on my graph. I'm going to connect my dots and extend my line. And it's easy to write an equation in slope-intercept form given a graph because all you need to do is look at the y-intercept. So I'm looking where this line is crossing my y-axis. That's going to be my b. And then I would find my slope like we did earlier in this video. And that's going to be m. That's going to be what's attached to our x. Okay, our next form is standard form. So for a lot of people, it's easier to just look at standard form and rearrange it so that it is in slope-intercept form, because if we're comfortable with slope-intercept form, then we don't have to memorize these other methods of graphing. I'll show you both. So if I have it in standard form, I can rearrange my equation so I can solve for y, essentially, so that I'm in slope-intercept form. So if I'm solving for y, we're trying to get y on a side by itself. So I'll subtract 2x from both sides. I'm going to bring down my -5y. -2x minus 10. I'm going to divide both sides by -5. And I'm going to get y equals +2/5 because it's a negative divided by a negative, so that just makes it a positive, plus 2. So that makes graphing really easy because I would just plot my y-intercept, which is 2. And then I would use my slope, which is 2/5. So we go up 2 and right 5 and plot a second point. And then I would connect these dots and extend the line. Another way you can graph from standard form is you can actually plug in 0 for your x and solve for your y, or plug in 0 for y and solve for x. So the idea behind this is you would graph your equation by doing the x and y intercepts. So essentially, if I find my x-intercept and my y-intercept, that makes graphing very straightforward because I already have 2 points and I just have to connect my dots and extend the line. Over here, we are going to look at it by solving as well. So I wrote it really tiny down here, but essentially in point slope form, you're given a coordinate, you're given this coordinate x1, y1, and you're given the slope. So if I'm given a coordinate and the slope, I can graph it by just graphing the coordinate. So this is a minus sign. So your coordinate's gonna have the opposite signs than what are in here. So the coordinate I would be plotting is -1, +5. So if I plotted that, it would be -1, +5. And then I would use the slope, which is -3. So we would look at that as -3 over 1. And we would go down 3, right 1. Down 3, right 1. But I don't have to know this form. I can just solve and put it in y-intercept form. So if I solve to put it in y-intercept form, the first thing I'm going to do is simplify both sides. We know that that is always important, so I don't want these parentheses, so I'm going to do the distributive property. And -3 times 1 is -3. And then all I have to do is add 5 to both sides to get this y on a side by itself. So we get -3x plus 2. And I would go to plot this, which is perfect because it's what I got when I plotted the other points. So I would go to +2 and I would put my y-intercept because that's what we got in our equation. And then I would go down 3 because my slope is -3, which means it's -3 over 1. So I go down 3, right 1. And then I would connect my dots and extend my line. The only other thing I want to touch on in this video, even though we have more notes, we'll look at parallel and perpendicular lines in the next video, is just what a horizontal and a vertical line look like. So I know that if I have an equation that's just y equals a number, it's going to create a horizontal line, which is a line that has 0 slope because it has a run, but it doesn't have a rise. So what ends up happening is I'm doing 0 divided by some number, and 0 divided by anything is 0. So a horizontal line, in this example, we have y equals 1. I would just go on my y-axis, since it's y equals, and I would find 1, and that's where I would draw a horizontal line. And then for our vertical line, it's going to be the same exact type of approach, except for when it's x equals a number, we create a vertical line, and a vertical line has a rise but no run. So if you are trying to find the slope, you would try and divide by 0. We can't divide by 0 and get a real number, so we call this an undefined slope. So if I have the line x equals 2, on my x-axis, I'm going to find 2, and I'm going to draw a vertical line.